Hello viewers, we are going to consider a question on the application of partial differentiation. And so from the question, we have if y equal to wx cubed over d raised to power 4, find the percentage increase in y when w increases by 2%, s increases by 3%, and d increases by 1%. So this is a typical question on the application of partial differentiation. So we are going to go into the solution immediately. And so our formula is y equal to ws cubed all over d raised to power 4. And so it means y is a function of w, s, and d respectively. So y is a function of these three variables. So in order to go about it, and note, if it is said that w increases by 2%, it means increase will be positive, so it's going to be positive. Increases by 3%, positive. Decreases, so it's going to be negative. So when we are going to solve the question, you see how this is being applied. So looking at this question, we can say that y, looking at the question, we can say that y is a function of w, is, and d. Okay, so we are going to partially, because it's partial differentiation, we are going to partially differentiate y with respect to each of these variables. So the first one is, if we have to differentiate y partially with respect to w, this is going to, if we differentiate y partially with respect to w at this point, let's call this equation 1. So we differentiate y with respect to w at this point, because this is 1. So 1 times 1, this will be 1, because we are considering only w. So every other thing will be left kept constant. So this will be 1 times w raised to power 1 minus 1 x cubed over d raised to power 4. So this will give us 1 times w. Of course, w raised to power 1 minus 1 is w raised to power 0. So this will be 1 times w raised to power 0 s cubed all over d raised to power 4. And so this is going to give us that our change in y over partial derivative of y with respect to w raised to power 0, any number raised to power 0 is 1. So 1 times 1 is 1 times s cubed is s cubed divided by 4. So a change in w with respect, a change in y with respect, partial derivative of y with respect to w will be s cubed over d raised to power 4. So that is for w. Then again, similarly, from equation 1, we are going to also consider the partial derivative of y with respect to s cubed. So partial derivative of y with respect to s now, s cubed, s rather. So because we are considering s now, this and this will be kept constant. So we have w over d raised to power 4, and then we are differentiating s cubed now. So this will give us normal way of differentiation, dot 3 times s raised to power 3 minus 1. And so this is going to give us w over d4 d raised to power 4. 3 minus 1 is 2. So this will give us dot 3 times s raised to power 2. So our final answer will be w dot 3 s raised to power 2 all over d raised to power 4. Okay, let me take it to this other side. So our final answer is going to be this times this is 3x squared times w will be w. So if we multiply that, we are going to have 3ws squared all over d raised to the power 4. So we are done with that now. So we now differentiate y with respect to d from equation 1 again. From equation 1 again. So partial derivative of y with respect to d will be. Now we know that this d is divided by is down. Okay? Is down. So what it implies is we are going to write for differentiating y with respect to d, we are going to rewrite our equation to be w is cube d raised to power minus 4, because we know that 1 over d raised to power 4 is the same thing as d raised to power minus 4. The essence of doing this is to make it possible for us to differentiate this without issues. And so if we are differentiating it, we are going to have, since this is constant, we are not considering this, so we keep it constant, w is cube, and then we are differentiating this. So this will be minus 4 times d raised to power minus 4 minus 1. So this is going to give us w is cube d raised to power minus 4 minus 1 is minus 5. So this one will give us dot minus 4 d raised to power minus 5. So our final answer for that, will be minus, okay, let me start with this. W is cube minus 4, okay, let me do it this way. We are going to have minus 4 d raised to power minus 5. W is cube. Okay. So W is cube. So when we have that, W is cube. So we can rewrite this to be this over this will be equal to, because this is negative, so we can bring it down, because of course we know a raised to power minus 1 is the same thing as 1 over a. So d raised to power minus 5 is the same thing as 1 over d raised to power 5. So we are going to have minus 4 w is raised to power 3 all over d raised to power 5. So now we've gotten the partial derivative of y with respect to w to be this answer. We've gotten the partial derivative of y with respect to is to be this answer. We've gotten the partial derivative of y with respect to d to be this answer. So having done that, we are going to introduce a formula that we use to solve this question. And so the formula was for us to find the percentage increase in y. The percentage increase in y. So you know that increase, the symbol for increase will be this. This is the symbol for percentage increase in y. Will be equal to, we are going to, for us to determine the percentage increase in y, we are going to use this formula that I'm going to write. It's very simple to generate the formula. So it's going to be partial derivative of y with respect to w times change in w plus partial derivative of y with respect to, okay, we have taken partial derivative of w with respect to partial derivative of y with respect to w times change in w plus, we take this on partial derivative of y with respect to is times change in is and plus finally the partial derivative of y with respect to d times change in d. So this is the formula we are going to use in solving this question. Like, look at what I did. You take the change in y, that's the increase in y, will be partial derivative of y with respect to w times change in w, plus partial derivative of y with respect to is times change in is, plus partial derivative of y with respect to d times change in d. So we've gotten the values for partial derivative of y with respect to w, that of y with respect to is, and that of y with respect to d. But we don't have the value of, we've not been able to bring out the value of change in w, change in is, and change in d. So that's what I want to do. Now from our question, if we go back to our question, we're told that w increases by 2%. W increases by 2%. Since it is by 2 multiplied by 2, it means, and it's percent, it means our change in W is going to be 2W divided by 100. And it's going to be positive because it is an increase. Since they said increases by 2%, so 2 by W, because we are referring to W increasing by 2%, divided by 100 because we are talking about percent. Now, similarly, our change in is will be equal to, from the question we are told that is increases by 3%, so that will be 3 is all over 100, and it's going to be positive because it is an increase, okay? And now, finally, we are told that our D we are told that our D also increases by 1%. So okay, let me use this decrease and this one to be decreases by 1 so that I can use it to so we're told that D decreases by 1. So because they said D decreases by 1 is going to be negative now. So our change in D equal to minus D, because it's 1. So needless writing 1D here, divided by 100. So we are using negative here because we are talking about a decrease in D by 1%. So normally it should have been 1 times D over 100, but 1 times D is the same thing as this, so that's why I'm writing minus D over 100. So having gotten this, we can now slot in all the value of this, and that of this into this equation. Let's call this equation, let's call this equation 2. So let's solve from here. Let's take this out. So let's rewrite our equation 2. Our equation 2 is change in y equal to partial derivative of y with respect to w, change in w, plus partial derivative of y with respect to is, partial derivative of times change in is, plus partial derivative of y with respect to that of d times change in d. Okay, of course you've noted the difference between when I'm saying partial derivative, which is this, and change. You've noted the difference between the symbols. So we bring in the values now. Partial derivative of y with respect to w is this, so we write that value, s cubed over d raised to the power 4 times our change in w is 2w over 100, so we write 2w over 100 plus, we are done with this, we enter this. Our partial derivative of y with respect to is is this. So we have 3WA squared over D raised to power 4 times, because of this. Then I change in A's is this. So we have 3S over 100 plus. Note we are substituting into this equation here. So I change partial derivative of y with respect to D is this. So because it is negative, we remove this plus here, right? Minus 4WS cube all over D raised to power 5 times our change in D. Our change in D here is minus. Our change in D is minus. So we have minus D over 100. So we are going to solve it now. So let's look at what we have here. So S cubed times this will give us 2WS cubed over 100 D raised to power 4. Okay, let's do it that way. Plus this times this times this will give us S squared times 3S squared will give us 3S cubed. So times 3W. So we have 3WS cubed all over D raised to power 4 times 100 will give us 100 D raised to power 4. And of course, you know, minus this times minus this will give us positive. And then this times this. So we are going to have plus 4. Okay, let's say plus 4D, because we have D here. W is cube all over D raised to power 5 times 100 will give us 100 D raised to power 5. Okay, so this is equal to. So we've gone this far. So but we continue, so that if we look at this question, if we look at this, what we have here rather, we have S cube here, we have S cube here, and we also have S cube here. So we can actually bring it out because we have to factorize the numerator and the denominator. Again, we have W here, we have another W here, we have another W here, so we can bring it out. And then what is common here? 100 D4 is common, 100 D4, 100 D4. So let's factorize it. So because we have S cube, S cube, S cube, we bring it out. Okay, let's start with W. We have W, 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 we write it out. So we write out the W because it's common here, and common here. So we write it out. And again, we know that S cube is common here, and common here. We write it out. So when we write it out, and let's also do it for this before we can. Now we know 100 is common here, so we say over 100. And we know D4 is common here, We can also factorize out D4 here, so we have D raised to power 4. So let's see. Now, if we bring out W, okay, we can keep 100 and just factorize D raised to power 4. Let's say that if we have to do our stuff, it will be easy. So let's just keep D raised to power 4 and leave 100. So that when we do our division, we can have what we are looking for. Now, if at this point, considering this, we have WS cube. Now, it means if we bring out WS cube from here, what will be left here will be 2. And if we bring out D4 from here, what will be left will be 100 plus. Now, if we bring out WS cube from here, what will be left will be 3. And if we bring out d4 from here, what will be left will be 100 plus. Now, if we bring out ws cubed from here, what will be left will be 4d. Oh, we would have cancelled out here, d here, 1, d here, 4. Okay, so if we bring out ws cubed here, what will be left here will be 4. What will be left here will be 4. And if we bring out d raised power 4 here, what will be left here will be 100. Okay, we've gotten that. Let's move down here. So we have that our change in y equal to ws cubed all over d raised power 4 into 2 divided by 100 will be 0.02, right? This is 0.02 plus 3 divided by 100 will be 0.03 plus, and then 4 divided by 100 will be 0.04. Okay? Divided by 100 will be 0.04. Okay? So 0.03 plus 0.04 plus 0.02 plus this will give us 0.05, and this will give us 0.09. So our change in y will be equal to ws cubed all over d raised power 4 into 0.09, because when you add this by this, it will give you 0.05. 0.05 plus 0.04 will give you 0.09. And so recall that if you look at this, you realize that this is the same value here. So you say recall that ws cubed over d raised power 4 equal to y, which is this value. So we are going to bring in y here. So we have that change in y equal to, because this is equal to y, we have y into 0.09. So that is what we have as our answer. Now, what does this imply? Because this 0.09 is positive, it means y increases by 0.09 or y increases by 9%. So you can either say it means the result means that y increases by 0.09 or by 9%. So we are saying it increases because the answer is positive here. Assuming it was negative, it would have been that y decreases by 0.09, but since it is positive, we say that y increases by 0.09.